Hello class 12 students. Today we'll be studying in particular about the structure of maltose, sucrose and lactose. All these three are disaccharides, okay? And since they are disaccharides, they are made up of two monomeric units. So all of them, maltose, sucrose and lactose, have the same molecular formula. What differs is the bonding in their structure. So let's discuss about maltose first. So maltose formula is C12H22O11. So whenever it is hydrolyzed in acidic medium, then what we get? We get two molecules of alpha D glucose. So we get alpha D glucose, that is C6H12O6 plus C6H12O6. So this is also alpha D glucose, and this too is alpha D glucose. So now let's discuss about the structure, okay? So since I have taught you about the ring structure of glucose, so that will be very helpful in determining the structure of maltose. So here we have alpha D glucose, and the structure of alpha D glucose, as I had taught you in our previous class, is this one. So 1, 2, 3, 4, 5, and here we have CH2OH, and this is the sixth carbon. And here we have OH group on the upper side. So here we will be having OH here, alternate wise, up, down, okay? And since it is what? Alpha D glucose, so you know at carbon number 1, alpha means OH will be present at, this will be present below the plane of this molecule. And above here we have hydrogen. So this is one molecule of alpha D glucose. Similarly, it is combined with another molecule of what? Alpha D glucose. So let me draw the structure of another molecule of alpha D glucose. So this is, here we have CH2OH, here OH here, up, down, and since this is alpha, OH will be placed below the plane. So and the rest of the unoccupied ones are what? Hydrogen. So this is hydrogen, hydrogen, hydrogen. I hope this way of writing the structure is very helpful, okay, for the structures of glucose, fructose and other compounds. So here in maltose, what happens is, this is carbon number 1, 2, 3, 4, 5 and 6. This, please, you have to be very careful. The carbon number 1 OH group of this molecule, okay, and from the another molecule of alpha D glucose, from the fourth position, this OH, they will be eliminated as what? Water molecule. As a result, there will be a bonding between this oxygen at carbon number 1 of this alpha glucose to this carbon number 4 of another alpha D glucose. So this is very important. Please remember, okay? The bond formation is from carbon number 1 of this molecule to carbon number 4 of another molecule of alpha D glucose. So once you eliminate the water molecule, so let me write the structure here now. So what will happen? Minus water. So we get the structure as CH2OH. Here we have OH here, OH, OH, and here you have to remember, okay? Now let me write another molecule here. At last I will be showing that bond formation between this carbon and this carbon. So here we have CH2OH, and here we have what? Hydrogen. OH was placed here, so OH here, here, and since it is alpha, OH will be present here. So the rest of them are what? Hydrogens. Now since the bond formation takes place from this oxygen at carbon number 1 and this carbon at carbon number 4, so we have a bonding. Okay, while writing the bonding, please you have to look at the carbon atoms which are bonded. Now see, this is carbon number 1, 2, 3, and this is 4, 5, and 6. So this is carbon number 1, 2, 3, 4, 5, and 6. So here we have hydrogen, hydrogen, and hydrogen. This molecule of glucose, alpha D glucose, and this molecule of alpha D glucose is linked to this oxygen. Okay, and this linkage is known as what? Glycosidic linkage. It is what? Glycosidic linkage. And this is the particular structure of what? Maltose. Okay, so it's very easily derived from, if you know the structures of monomers, that's alpha D glucose. So a molecule of water will come out from carbon number 1 of one molecule and carbon number 4 of another molecule. Another molecule of what? This alpha D glucose. This water molecule has eliminated, and now the bond formation between this carbon and this carbon takes place by the help of this oxygen, as it is shown here, and this is known as what? Glycosidic linkage, and this is the particular structure of maltose. So hope this is clear now. So let me write the structure now. Let us discuss the structure of lactose. Okay. Now, so we are going to discuss about the structure of lactose. Number 2, lactose. Now the formula of lactose is the same, that is C12H22O11. So whenever it is hydrolyzed in acidic medium, now again this is made up of 2 monomeric units, and the monomeric units in lactose are beta D glucose and beta D galactose. So you have to remember this one, okay? So here we have again C6H12O6 plus C6H12O6. So one is what? One is beta D glucose and the other one is beta D galactose. So this is beta D glucose and this is beta D galactose. So please you have to remember the monomeric units of each these disaccharides. Okay. So once you know the monomers, so you can write their structures now. This beta D galactose, I'll tell you what is the structure and it's very simple. Okay. So now please look at it very carefully. So let me draw the structure of this beta D glucose as you already know it. It is, so here we have CH2OH, OH here, OH, OH, and since it is beta, OH will be present at above the plane at carbon number 1. So this is the structure of what? This is the structure of beta D glucose. Now let's write the structure of beta D galactose now. Okay. So I'll tell you how you have to write it, and it's very simple. It's almost same as that of glucose. So this is carbon number 1, 2, 3, 4, 5, and 6. So here the difference between the structure of this beta D glucose and beta D galactose lies, please listen, lies in the positions of carbon number 4. At carbon number 4, here what we have? Here you have in case of beta D glucose or in glucose, you have hydrogen above the plane and OH below the plane. But in galactose, it will be just the opposite. You will be having OH above the plane and hydrogen below the plane. So this is the only difference between there's alpha beta D glucose and beta D galactose. Please remember, it's at carbon number 4. The position of OH and H are just the reverse of that of what? Beta D glucose. The rest are same. So OH is here, OH, and since it is beta, so OH will be placed above the plane, hydrogen, hydrogen, and hydrogen. Now here again, as we did in the last case, in the case of maltose, again here a molecule of water will be eliminated. What will happen? A molecule of water will be eliminated from this again. So this water molecule will be eliminated. So minus H2O. Now these two are linked through carbon number 1 and carbon number 4 by the help of this oxygen. So let me write the structure. So we have O. Here we have CH2OH. Here we have OH, 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 and now here we have hydrogen. So since this is linked to another molecule, I will be writing the oxygen, the connection of the bond between this and this at last. Okay, so let me write the structure of another molecule. So here we have CH2OH, and since this is what? Glucose, here we have hydrogen and hydrogen here. So OH here, OH, since it is beta, OH will be here and hydrogen's here. Okay, here we have what? This is. So here we have hydrogen and hydrogen. So let me check the structure once again. So CH2OH, OH, OH, OH. Okay, now this is the structure of up, down, up, down, up. Okay, now this is fine. Now here the bonding between this molecule of beta D galactose and beta D glucose takes place through carbon number 1 and carbon number 4 by the help of this oxygen. So let me write the structure then. So this is bonded to this. I suggest you to make a curve, okay? Not an edge, not a sharp point as it is given in the book, because this means what? In chemistry, this means a carbon is present, okay? Which is wrong. So what you have to make? You have to make a curve so that you won't be confused, that no one will be confused. In fact, now if you draw this way means what? It can also be named that this carbon is present. So please don't do that, okay? As it is given in the book. So you make a curve, and this is the structure of what? Lactose. So this is the structure of what? Lactose. So now let's discuss about the structure of sucrose. So this is the structure of lactose. So now let's discuss about the structure of sucrose. This is sucrose. Now sucrose again has the same formula, that is molecular formula C12 S22 O11. So whenever it is hydrolyzed in acidic medium, what we obtain two monosaccharides, and one is our alpha D glucopyranose. The formula is H12O6 plus C6H12O6. This is alpha D glucopyranose, and this is beta D fructo. It is furanose. See, look at the difference here. It is pyranose and this is furanose. Pyranose means you have a 6-member ring, and here this fructo furanose means it has 5-member ring. Okay, you have to remember this. Now let's come to the structure of this sucrose. Please remember this. Fructo furanose means 5-member ring. So let's write the structure here now. So we have what? We have this. What we had? We had alpha D glucose. Yes or no? So here alpha D glucose structure. You already know it. So here we have CH2OH, OH, 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 and this is alpha. So OH will be placed at the bottom below the plane. Okay? So this is the structure of alpha D glucopyranose. Now let me write the structure of this beta D fructofuranose. You have to remember it, please, okay? So now furanose means it has 5-member ring. So 1, 2, 3, 4, 5. So here we have, since it is what? Beta. Therefore OH will be placed here, and here this is, since it is beta, OH will be placed where? At the above the plane. And here this is CH2OH. This is carbon number 1, 2, 3, 4, 5, and 6. CH2OH. Okay? Say 1, 2, 3, 4, 5, 6. CH2OH here, and as we did for glucose, up, then alternate positions of OH groups. OH here, and again it goes up. Below it is hydrogen, and here it is hydrogen. Please remember this structure. Okay, and here it is what? Hydrogen. Now this is the structure of what? This is the structure of beta D fructofuranose. You have to remember this. Now here again, what will happen? This water molecule will be eliminated, and the bond formation will take place between this carbon number. This is okay. This is not the second carbon. Here it has to be OH, OH, OH. It has to be from carbon number 1. Please remember, okay, not from carbon number 2. 1, and here it is 2. So a molecule of water will be removed from OH from here, and hydrogen from here will be removed as what? A water molecule minus water. As a result, what we have? We have a structure CH2OH, OH, OH, OH. Here we have what? Hydrogen, and here we have CH2, OH, H, up, down, H, then again it goes up, OH, and since it is beta D fructofuranose, what will happen? So let me write this structure properly so that I can show you the glycosidic linkage. So let me draw it to the side so that this is only 5-member group, so that this bond and this bond, okay, will be almost in a line. So while writing, it's not perfect in the line. So while drawing the structure in your copy, please write in a straight line. Okay, these two are linked by oxygen. So this bonding between this alpha D glucopyranose and this beta D fructofuranose is known as what? Glycosidic linkage. And this is the structure of sucrose. So in sucrose, don't forget, the bonding takes place from this carbon number 1 of alpha D glucose and from carbon number 2, this is carbon number 1, 2 of this fructofuranose. This is beta D fructofuranose. So this is the end of today's class. So you keep on practicing these different structures so that it will be easier for you to remember it. So we'll be seeing you in your next video. Till then, take care. Thank you.